Hi, my name is Andrea Pergola. I am the CEO of NG Detector and one of the engineers in the development team of the GonioProbe. The GonioProbe is a radiation detector probe used in medical application. The main component of the system is the probe, a charging unit, and a control unit. Breaking down further, the electronic inside the probe has an analog block, an hardware accelerator, a memory, an accelerometer, a real-time clock, an active driver, and a Wi-Fi with big microcontroller block. Now we are happy to give you a brief demo, hoping to wow you with the unicity and technical quality of our device.
We will now do a brief demo for you to illustrate the unique characteristics of the GonioProbe. Using a radiation source of cobalt-57, we will observe how the navigator works to locate and pinpoint the isotope. At this moment, the radioactive source is at an angle of approximately 45 degrees to the GonioProbe. In order to quickly navigate to this source, our control unit displays accurate and correct instructions for us to follow. As I move the probe around the radiation source, the direction instructions I am given by the navigator will simultaneously change. Having clearly understood the exact position of our source, and by moving the probe up to it, we will be given the lock-on target signal. We are concurrently given the exact position of the probe relative to the source, as well as the exact distance between its surface and that of the isotope. To better verify the probe's ability to discriminate between depths of the detected source, we can insert a spacer of approximately 80 millimeters. By doing so, we will immediately see this variation repeated on the monitor. We will see a new number for the detected counts, which of course will have decreased, as well as a new number of compensated counts.
First, I will place the cobalt-57 215 kilobecquerel source in the region of the axillary cavity to simulate a lymph node. Then, with the GonioProbe, I will identify the exact location of the node. You will see how the GonioProbe guides my hand to the emitting source, the navigator. I have located the lymph node. Let's see how accurate a position I can get. See how the counts on the monitor increase the closer I get, the lock-on target. Now that we are centered, the GonioProbe also reveals the depth of the node. This is precise up to a depth of 15 millimeters, and very important for the surgeon to know.
Hi, my name is Roberto Bani and I am the inventor of the GonioProbe you are being shown today. The detection core consists of 5 LISO crystals providing the same performance as a traditional collimated detector. The key difference is that in the case of the GonioProbe, the conipation forms an active part of the technology. The directional capability of the system is guaranteed by the weighted counting corresponding to the solid angles submitted by each crystal.
The inherent and unique advantages of the GonioProbe's operational characteristics are many. It is alone, for example, in having a built-in navigation system that takes the surgeon right up to the radiation source in real time. It does so with extreme accuracy, and it is very fast. It has a very low false negative rate, resulting in a better diagnostic reliability. Through its operation being so intuitive, there is a reduced requirement for training of the operator. This is quite unlike standard probes that require extensive operator training across 40 or so procedures. These characteristics, unique to the GonioProbe, translate into a number of important and unopposed benefits. There are, for example, inherent cost savings, represented by the time reduction of a procedure when using the GonioProbe, less staff costs, operating theatre costs, post-operative problems through potentially having missed nodes. Of course, an accurate diagnosis of the node's position will also translate into more minimally invasive procedures, with a corresponding reduction in the number of total axillary dissections being required. Exposure to radiation will be less, both in terms of time and dose, and both for the staff and indeed the patients. The high positioning accuracy means there is a less likelihood of missing lymph nodes, positive for metastasis, with the added advantage of early staging being possible. In essence, better results for significantly less overall cost.